Hello! In this video we will look into the importance of semantically interoperable data and how this can be achieved. Let's start. First of all, semantically interoperable data schema means that information between systems can automatically be exchanged by sharing common meaning. And this is achieved through universally accepted standards. But why is standardization important? Interoperability is one of the four principles of fair data: findable, accessible, interoperable, and reusable. In addition, the European Interoperability Framework defines technical, semantic, legal, and organizational as interoperability layers to successfully improve the quality of European digital public services. And for all this, standardization is key. Semantic interoperability can be improved using standardized and established data schemas, taking also into account existing vocabularies for domain-specific context. So, linking data schemas or parts of them with standardized ones is greatly beneficial for semantic interoperability. In addition, the use of controlled vocabularies, code lists, and standards is also critical to ensure consistent metadata, because metadata of good quality is key not only for interoperability but also data findability. The main challenge in the semantic interoperability landscape mostly comes from the inconsistent data vocabulary use or the use of non-standardized schemas. Many organizations and data provider groups use custom data or metadata schemas, which is problematic. So, how can linking data schemas improve the open data ecosystem and make it more user-driven? And in what ways can it enable users' interaction with open data? The role of ontologies and data models in search capabilities within large collections of data is critical. The integration of diverse data sources becomes feasible because ontologies frame the data conceptually and provide a common understanding of terms and their relationships. Large language models have been in the spotlight for undertaking the task of mapping common elements between different ontologies. The results of this process could systemically be integrated to provide recommendations on semantic mappings. So, given a custom metadata schema by the user or organization, a set of guidelines on how to make this schema or data semantically interoperable can be provided. Semantically interoperable data would mean connection with existing bodies of knowledge and data repositories, improved findability, and more relevant retrieval of results. Now let us consider an example in the cultural heritage domain. Supposing we have two art galleries, Gallery 1 and Gallery 2. Both art galleries have their own custom schema to describe their artifacts. For instance, Gallery 1 might name a painting art name, while Gallery 2 painting name. Also, the date of painting creation might be the field creation date in one and creation year in the other. Right now, data information across the galleries cannot flow seamlessly, although we understand that both refer to the same painting information but using different fields for it. A trained large language model on cultural heritage could identify those mappings and propose that they get replaced by fields of an existing standardized ontology of this domain. In this case, for example, CRM is a comprehensive artifact representation schema, so the system or model could return a number of recommended links to this standardized one. So, in this case, Galleries 1 and 2 would be semantically interoperable. More specifically, the general architecture of such a process could take the best of machine intelligence and human expertise, which is necessary for domain-specific context. It would work like this. First off, a large language model would be trained using expert-curated data to ensure accuracy of information. Then the model, for instance Llama, ChatGPT, GPT-4, or a combination, would propose mappings and links of various schemas to standardized vocabularies. Those vocabularies could be standard ontologies of the domain or recommended mappings from the linked open vocabularies repository. Human domain experts will validate those produced mappings, and this would be an iterative process until consensus is reached. This means the mappings would then be performed and possibly served as contributions to the linked open data cloud. The outcome of this process would be coherent data integration, as it would ensure all data is aligned with standard vocabularies of this domain, but also proximal domains, provided that relevant links are identified. Semantic interoperability seems to be drifting farther away from the notion of creating one ultimate ontology to represent all existing knowledge. Rather, the focus is on linking existing knowledge representation schemas to enable interoperability. Taking the best of human and machine understanding, it could be that we are entering a new technologically enabled era for semantic interoperability and the discoverability of data and datasets. With the help of technology, as described before, future data publishers can get strong recommendations on how to make their own data schema interoperable by creating necessary links between them and standardized ones. This would result in improved conceptual and hierarchical relationships for information representation. Also, the produced links and mappings among the different ontologies would be an active contributory process to the linked Open Data Cloud.